Okay, so today we'll continue our exploration with graphs, and we'll talk about one way to traverse a graph. So it is called depth first search, or DFS. So depth first traversal or depth first search for a graph is similar to that of a tree. So the only catch here is that unlike trees, graphs may contain cycles. So to avoid processing a node more than once using a Boolean visited array. So we'll talk about that in the implementation of the DFS algorithm later. So a graph can have more than one DFS traversal. So we'll use this example to first give you a understanding of how it is performed on a given graph. So here we have a graph that contains a cycle, and it is a directed graph. So we have a array to store the visited nodes, and here is a stack. So first we'll know that the first node that we come to is 0, so we will just mark 0 as visited, and in the stack we'll have 3 nodes, 1, 2, and 3. So these nodes are the nodes that are connected to our current node, that is 0. So you can see from the graph that 1, 2, and 3 are all directly connected to 0. So these are our targets for the next step. And so we'll visit 1 here, and you will know that no nodes are connected to 1, so we'll go back to 0 and check the rest of the nodes that are connected to 0. These are 2 and 3. So here we'll continue with 2, and here we'll find that 3 and 4 are connected to 2. So in our last case, no nodes are connected to 1, so we have to go back and check the rest of the nodes. But like in this step, we can see that 3 and 4 are already connected to 2, so we don't need to go back. We can first go through the nodes that are connected to 2. We'll just all go the way all down, and that is also why it is called depth first search, because you will just follow one route until it is the end and you will go back. So 3 and 4 are still available, and here you will visit 4, and it is the last node. No other nodes are connected to it, so go back to 2 and you will find that only 3 is available here, and the last node that you visit is 3. So the depth first search is actually quite a easy method. And here we'll talk about the time complexity of this algorithm. So it is OV plus E. So V is the number of vertices and E is the number of edges in the graph. So the space complexity is also V plus E, because the extra visited array of size V is required, and stack size for iterative call to the FS function. And you also go to every place in the array 1, so OV plus E. And here we'll talk about some codes about the implementation of the FS using Java language. So sorry, I missed one I for the implementation here. And in our last activity, we talked about how to represent a graph in Java language, that is using adjacency matrix. So here we have a given graph here. It contains 5 nodes, 1, 2, 0, 1, 2, 3, and 4. And here is an adjacency matrix that we use to represent this graph. So we can know that we can review it here. So first we start from 0. there are 4 nodes that are connected to 0, that is 0, 1, 0, 2, 0, 3, and 0, 4. So these nodes are not directed, these vertices are not directed. So you can go from 0 to 1, and you can also go from 1 to 0. And that's why we have 0, 1, 0, 2, 0, 3, 0, 4, and 1, 0, 2, 0, 3, 0, 4, 0 all set to 1, and the rest of the vertices are not in this graph, so they are all 0. And this is the adjacency matrix for this graph. And here is the approach that we will write a DFS code, Java code for to present the traversal. So first we'll create a matrix of n times n. So and set all the vertices to 1. So this is the adjacency matrix part, and we have already finished that. And after the adjacency matrix has been created and filled, we'll call the recursive function for the source, that is vertex 0, that will recursively call the same function for all the vertices adjacent to it. Also keep an array to keep track of the visited vertices. So here we will set visited I to true. This is a Boolean type array to represent that vertex I has been visited. So if we have, for example, if we will not use this example. So here, if we have already visited 2 and now we are at 3, so 2 nodes are connected to 2, for example, 0. 2 nodes are connected to 3, 2, and 0, and we know that, for example, if the visited 2 is true, so we'll not go to this way, we'll choose another path. So that is the use of this array. And here we'll check the Java code. So first we'll use a method called addEdge that has 2 parameters, x and y, to create the adjacency matrix. So if we pass in the x and y, we'll just set these values to 1 for the undirected graph. So if it is directed, you can write this line, you'll just delete it. So here is our method for the depth first search. And here we are just traverse the whole length of the adjacency matrix, and if we have not visited this graph, and if we have not visited this node, the next node, and the next node is connected to our current node, we'll just do a recursive call, that is, we visit the next node and set it as visited. So you can see from this part of this method that when we come to a node, we'll just first set its value as visited. And here is what we will write in our main method to complete this depth first search process. So here is the line to define a new adjacency matrix, and here is our cause of the addEdge methods to fill this adjacency matrix. And here is the line of code that we create a new Boolean type array to store the visited nodes. And at last, we'll just need to start from 0 and set it as visited, and it will automatically do the recursive calls and until it gets to the end that all the nodes are not visited. And that is how you will write it in Java code. So that is all for today's activity. Thank you.